What if a villa is capable of lifting 400 tons of steel above a Category 4 hurricane? We begin the dismantling of illusions about marine homes. 8 billion humans crowd into just 29% of the Earth. The remaining 71% is water. For the top 1% of the wealthiest population, the ultimate asset is no longer gold or land. It is absolute isolation. From satellite orbit, the continents appear as glowing webs of overpopulated megacities. Down in the dark void of the open water, a single high-tech capsule anchors in the abyss. We analyze 8 floating fortresses that defy the most aggressive environment on the planet. The ocean is not a resort. It is a ruthless testing ground for extreme engineering. Saltwater devours unprotected steel at a rate of 0.005 of an inch per year. A storm wave strikes with a devastating force of 6,000 pounds per square foot. Outside the reinforced composite shell, the deafening roar of crushing water and 130-mile-per-hour winds tears the surface apart. Inside, absolute silence, an acoustic vacuum. Triple-layered glass neutralizes the chaos. Zero vibrations, pure survival mechanics. To colonize this lethal territory, architects rewrite the laws of physics. The first target is Panama. The Seapods project eliminates the static foundation entirely. 3 meters above the waterline, 180 degrees of unobstructed view, $3 million per unit. But before dropping these futuristic alloys into the open sea, engineers strip the entire structure down to the millimeter and pack it into the rigid steel geometry of global freight. We start at the base level, mobility. Before challenging the elements, the engineers of Floatwing challenged global logistics. How do you move a fully functional marine habitat across the planet? You dismantle it. Engineers calculate the framework down to the millimeter. Walls, decks, and structural beams detach into flat modular panels. The architecture collapses into raw geometry. A complete floating residence slides perfectly into 2 standard cargo containers, 40 feet of corrugated steel each. This breaks the geographical lockdown of traditional marine homes. Loaded onto a flatbed truck, hoisted onto a freighter, deploy it in any river or lake worldwide. Assembly requires minimal heavy machinery. Once locked together on the water, the structure activates its defense systems. The massive transparent facade relies on triple-layer glass equipped with a specialized ultraviolet filter. This creates a severe acoustic and thermal shield. Heat reflects, cold bounces off. The interior climate stabilizes without burning excess power. Technical autonomy takes over. The roof holds a dense array of solar panels. A compact chemical plant below the deck treats all wastewater. This setup pushes the habitat into total isolation mode. The systems guarantee 7 days of full off-grid autonomy, no external grid connection, no diesel deliveries. The operational cycle sustains continuous human comfort while dropping the carbon footprint to absolute zero. If the rigid geometry of a cargo container limits Floatwing, the next project copies the most perfect shape in hydrodynamics. How do you build a maritime structure that survives ocean storms without a massive keel or heavy ballast? Look at a simple drop of water. Surface tension pulls liquid molecules into a flawless sphere, equalizing external pressure from all directions. Naval architects scaled this microscopic physical law up to a multi-ton floating habitat. The Anthenea pod operates as a macro drop. Instead of fighting the ocean and cutting through water with a sharp bow, the spherical hull forces incoming waves to wrap smoothly around its exterior. Fluid dynamics absorb the impact. The kinetic energy of a crashing swell simply dissipates along the curve rather than slamming into a flat wall. Complete stability. Zero structural fatigue. The capsule becomes virtually unsinkable. This continuous geometry dictates the power grid. The entire upper hemisphere functions as a 360-degree solar dome. High-efficiency curved photovoltaic panels capture scattered light from every possible angle, harvesting energy continuously from dawn until dusk. No diesel combustion, no engine vibrations. A silent flow of current replaces the heavy mechanical hum of traditional marine generators. Below the waterline, the habitat must hold its position without tearing through delicate coral networks. The engineering team utilizes a sand screw eco anchor. A solid steel helix drills precisely into the soft seabed, locking the massive structure in place with maximum holding power but a microscopic physical footprint. Above this tether, the interior spreads across exactly 50 square meters of highly engineered living space, balanced flawlessly around a central underwater observation port. The primary systems enter standby mode. A spherical shadow drifts seamlessly above the protected reef, leaving absolutely no trace in the pristine current below. From a capsule gliding across the surface, we shift to a structure that pierces the water on a vertical axis, utilizing the raw physics of buoyancy. Above the waves, it appears as a fragile fragile white dome hovering in midair. Below the waterline, it is a heavy industrial anchor engaged in a perpetual wrestling match with the ocean. Total contrast. A habitat weighing over 30 tons balances completely on a single point of support, just like an iceberg. The stability relies on a deep water spar platform. A massive steel cylinder plunges straight into the dark marine current. Inside the central mass, trapped air generates extreme upward thrust. The steel float violently pushes the upper mass toward the surface. At the exact same time, tons of heavy iron ballast at the base pull the entire framework downward. The center of gravity gets permanently locked deep underwater. The structure physically cannot tip over. Zero pitch, zero roll. The environment above is equally aggressive. Heavy tropical winds howl across the Panamanian coast, but the moving air finds no flat walls to strike. The dense kinetic flow smoothly wraps around the aerodynamic fiberglass shell, slipping away without transferring destructive force. The living quarters remain completely static exactly 3 meters above the breaking waves. Inside this floating vault, 73 square meters of usable space spiral seamlessly through 3.5 vertical levels. But engineers did not design the sea pod solely for human isolation. The primary mission is ecological regeneration. The submerged steel column functions as a massive biological catalyst. Low voltage electrical currents pulse through the underwater metal grid. This electric field triggers rapid mineral accretion, pulling dissolved calcium directly from the seawater. The structure actively grows its own limestone shell, transforming into a skeleton for coral polyps. A once barren patch of sandy bottom rapidly evolves into over 150 square meters of thriving artificial reef. Sea pods merely touch the surface of the reef, but engineers in Dubai decided to descend into the critical pressure zone. The floating seahorse dominates the water column. 371 square meters of living space span across 3 distinct structural levels. The lowest tier sits completely submerged. Down here, physics turns hostile. Thousands of tons of seawater constantly press against the exterior. A heavy, relentless physical weight pushes inward on every square inch of the submerged shell. Standard architectural glass instantly shatters under this load. Engineers discarded traditional windows and deployed solid panels of military-grade reinforced acrylic. This dense, transparent armor withstands continuous hydrostatic pressure without a single microfracture. But extreme structural thickness creates a massive optical barrier. Standard thick materials bend incoming light. They distort the underwater environment, turning the view into a blurry magnifying glass effect. To break this barrier, engineers calculated the exact refractive index of the Persian Gulf saline water. They altered the material to match the acrylic's optical properties perfectly to the ocean outside. Light passes through both the dense salt water and the thick acrylic block at the exact same speed. Zero distortion, zero visual warping. Achieving this optical and structural precision demands massive capital. The base cost hits $1.3 million per unit, yet this budget funds more than just submerged architecture. The lower deck anchors directly to the seabed and supports a 60 square meter artificial coral garden, a biological matrix engineered specifically to breed and restore the endangered Arabian seahorse population. The material science achieves its ultimate objective. The thick military armor holds back the crushing depths, yet completely disappears from sight, erasing the physical boundary between the interior and the open ocean. Military glass withstands fluid pressure, but what happens when water turns into a contracting solid monolith? Outside the walls of Wilhelmi, a howling blizzard drowns out all other noise. The wind screams. Beneath the surface, the auditory reality shifts to the relentless grinding scrape of encroaching ice. Freezing water expands by 9%, generating a crushing force of up to 30,000 pounds per square inch. Traditional floating houses rely on heavy concrete pontoons, which easily succumb to this extreme lateral pressure. Wilhelmi takes a radically different approach. This floating residence actively resists the freeze through structural engineering. The foundation utilizes a rigid composite matrix borrowed directly from aerospace manufacturing and high-speed naval architecture. Instead of deploying brittle concrete, engineers cast advanced lightweight polymers designed to absorb and deflect immense mechanical stress. A total mass of 200 tons rests entirely on this specialized hull. The ice squeezes, the hull holds. Defeating the mechanical crush provides stability, but survival requires complete thermal sealing. Inside the living space, absolute silence replaces the deafening crackle of the freezing water outside. The architectural envelope features an insulation coefficient that drastically surpasses traditional high-end terrestrial builds. Heat generated by the internal systems remains securely trapped within a hermetic thermal vault, completely isolated from the hostile exterior. The composite armor neutralizes the crushing force, while the insulated core preserves the internal climate. The ambient temperature drops further. The lake permanently locks the structure in ice. Ice compresses slowly, but in Miami, the threat attacks at a speed of 250 kilometers per hour. A Category 4 hurricane approaches the coast. Sirens wail, evacuation orders flash across screens. But the owner of the Arcub 75 remains inside, calmly watching the dark horizon. Fast forward 12 hours. The storm makes landfall, ripping roofs from nearby houses. Yet this floating villa stands completely motionless above the boiling ocean. The secret lies in heavy engineering stolen directly from offshore oil rigs. 4 massive steel spuds, each 40 feet long, slide down from the corners of the vessel. They pierce the soft seabed and anchor deep into the limestone. Then, the industrial hydraulics roar to life. A deep, resonant hum vibrates through the deck. The system pushes down against the ocean floor with immense pressure. The entire structure begins to rise. 400 tons of glass, steel, and composite, the exact weight of a fully loaded wide-body passenger airliner, lifts smoothly into the air. The ascent stops at 6 meters above sea level. The hull completely detaches from the water surface. This mechanical elevation neutralizes the most destructive force of a hurricane, the storm surge. Waves smash into the steel pillars, but the living space remains untouched. Inside, there is zero rocking. You feel absolute immobility underfoot while chaos reigns just meters below. 36 kilowatts of solar energy flow through the independent power grid, keeping the hydraulic locks engaged and the heavy-duty climate control running without a single drop of grid power. No anchors to snap, no mooring lines to break. The structure transforms from a vulnerable boat into an unyielding artificial island. The engineering math leaves no room for doubt. The ultimate point of failure for this elevated fortress sits precisely at 250 kilometers per hour. Hydraulics defeat the storm, but the absolute enemy of any marine architecture is salt and time. The ocean consumes everything. Traditional fiberglass hulls blister under relentless ultraviolet radiation. Aluminum slowly oxidizes. In a marina packed with fragile white composite yachts, this vessel sits like an alien artifact, a massive silver monolith. At 26 meters long, the structure sacrifices speed for absolute permanence. Builders forge the entire hull from pure marine-grade stainless steel. This raw material choice represents a fabulously expensive anomaly in modern shipbuilding. Ordinary vessels require constant applications of toxic paint to survive the water. Here, molecular chemistry performs the defense. The steel alloy contains molybdenum. This specific element grabs oxygen from the air and instantly forms a microscopic shield across the hull, actively repelling destructive chloride ions found in seawater. No rust, no structural degradation, zero maintenance. The interior scale directly challenges terrestrial luxury. The layout spans 836 square meters. 3-meter ceilings rise above a handful of minimalist living quarters and vast entertainment decks, completely eliminating the cramped claustrophobia of standard nautical design. It is the spatial equivalent of placing a high-end urban penthouse directly onto a heavy industrial barge. Saltwater shreds standard ships in mere decades. This hull ignores the clock. It is an indestructible alloy resting in the tide, metal that will silently outlive its creators. We have studied the steel fortresses of the elite, but the true scale of engineering is revealed when technology descends to the masses. Copenhagen Harbor. The wind chill drops to freezing. Here, floating architecture transitions from individual extravagance to a scalable urban grid. The Urban Rigger project takes standard shipping containers, 4-ton steel boxes built for global freight, and engineers them into a buoyant housing complex. Billionaires hide behind custom superstructures. This system relies on raw industrial geometry. Designed by the Bjarke-Ingels Group, 9 containers lock into a strict triangular configuration. This shape acts as a physical shield. The angled metal walls deflect the piercing Scandinavian winds. They carve out a calm, protected courtyard right in the center of a hostile marine environment. The real triumph operates beneath the waterline. It is a masterclass in applied thermodynamics. Through a thermal camera lens, the invisible cycle becomes clear. Dark seawater hovering at just 2 degrees Celsius flows into the basement pontoon. Industrial heat exchangers capture the latent thermal energy hidden inside this freezing liquid. Compressors multiply that heat and force it upward into the living modules. The sheer thermal mass of an icy harbor converts directly into indoor climate control. Hydrosource heating, extreme efficiency, zero combustion, but bare steel leaches heat instantly. To defeat the Arctic cold, engineers line the inner walls with a microscopic defense mechanism, NASA Aerogel. Originally developed to protect Mars rovers, this synthetic matrix contains 99% 90% air. It ranks as the lightest solid on Earth. A translucent layer no thicker than a human thumb halts thermal transfer completely. The exterior steel turns to ice. The interior remains perfectly isolated. Solar arrays on the roof drive the heat pumps. Passive ventilation channels manage the internal airflow. This structure bypasses the real estate crisis entirely. Urban rigor exploits the unused surface of the ocean, turning city waterways into the next frontier of residential zoning. The prototype proves that megacities do not need to retreat from rising sea levels. They can colonize the tide. The modular grid expands, connects, and redraws the physical borders of the modern metropolis.